Assalamualaikum and hi everyone, welcome back to my video. Today we are going to talk about the reviews on descriptive statistics. So what is descriptive statistics, guys? Descriptive statistics is actually part of the process of the 6 steps of doing a statistical problem solving methodology. Remember, we discussed about this in our previous classes. Number 1 is to have an objective. You need to define ataupun to find out a very clear objective. And then after that, you can start with your data collection. Okay, so this is part of descriptive statistics. Now, the data collection, if you can collect your data from the whole population, so you don't need to do sampling technique. Remember, if you do need to, if your population is too large, okay, then you need to take a sample instead of collecting data from the whole population. You just want to collect the data from the sample. So you need to include sampling technique in your data collection. So once you're done with all the data collection, what do you do next? Okay, step number 4. Step number 4 is to do data classification and data summarization. Remember? So we talk about that, right? And then you also use in step 4, you also do graphical representation using various types of charts that we have here in statistics, right? Now, after that, all of those steps explained just now, step 1 until step 4, those are all the descriptive statistics. Okay, these are considered as descriptive statistics. We are basically just trying to describe the data as it is. Okay, describe the data using mean, median, mode, describe the data using graphical representation. So that's why it is called descriptive statistics. Okay, so if your data is collected from the whole population, okay, if the data is population data, so it is also considered or called as census data. Okay, you can immediately use whatever information you've gathered from the data summarization and all. You can immediately use that information to draw conclusion about your population. Okay, you can immediately draw conclusion about your population because the data is population data. Okay, but if let's say the data collected is not from the whole population but just from the sample of the population, then you need to use the information from the sample to make inferences about the population. Okay, so this part, okay, is called inferential statistics, the part where you go deeper into trying to understand what does this mean, median, mode value means about the data. Okay, so this is inferential statistics, the part where you try to make inferences about the population using information from the sample, or you draw conclusion about the population using information from the data population, from the population data. Okay, so now let's go into data summarization. I would like to elaborate more on the data summarization. What can you use? Okay, apart from doing the graphic representation, what else can you use to describe your data? Okay, to summarize your data. Now, I would like to call them as tools. Okay, we have different types of tools to describe data. Why do I call them tools? Okay, now let's try to understand this from a different point of view. Okay, let's think of any tools. Okay, any tools that comes to your mind right now. What is it? Okay, perhaps maybe a weighing scale. Okay, look at my screen now. So these are 2 different types of weighing scales. This is for bigger objects, this is for smaller objects, but basically both of them are used to weigh objects. Am I right? Okay, so this tool, even though there are 2 different things, okay, but they have the same function, which is to describe weight of an object. Okay, so this tool is used to describe weight of an object. Another example, a measuring tape. This is a measuring tape, this is also a measuring tape. Okay, both are measuring tapes, even though they're used in different conditions, okay, but both are used for what? Both are used to measure length. Yes, these tools are used to describe length of an object. Get it? So different tools has different function, okay? Different tools describe different aspect of an object. This tool describe weight, these tools describe length. So same goes to data. Okay, in describing data, we also have different types of tools that we can use to describe data, and I would like to categorize them as measures of central tendency, measures of variation, and measures of position. Okay, so these are the tools. These are all the tools that you can use to describe your data, to summarize your data, and also to understand your data. Okay, so we can categorize all these tools into three different categories. Okay, under the category of measures of central tendency, we have mean, median, mode, and mid-range. Under the category of measures of variation, we have standard deviation, variance, range, interquartile range, and coefficient of variation. And finally, under the category of measures of position, we have quartile, percentile, and decile. Okay, guys. Now, I'm sure that you are familiar with some of these tools. Okay, you already know what are these for, and you already know what are these three. Probably some of you already know what is interquartile range. Okay, so we're going to learn more about that later. But now, before we go deeper into this subtopic, I would like you guys to focus on three things. Okay, make sure throughout these videos and also the next video, okay, and also the next video, you will try to aim to understand, okay, what is it that you need to understand from all these different measures, okay, all these different categories of tools. What does it describe the data? Okay, how does central tendency help you to describe the data? How does measure variation help you to describe the data? Okay, and then how to do the calculation, and finally, once you have the calculation, how to interpret the calculated value. Okay, these three should be your main focus throughout this chapter 1.3. Ready? Now let's go to the first one. Before that, okay, let me just tell you that throughout this course, you don't need to show your calculation for mean, standard deviation, and variance, okay? No calculation needed. You can just use your calculator to find the values, okay? So please check out the 2 guideline videos which I have already posted in our Microsoft Teams, okay, to how to find sample mean, sample standard deviation, and sample variance using your calculator. And also, I would like to emphasize on this rule of thumb throughout this course. Okay, whatever calculation made, you need to write down your answer in 4 decimal places. Okay, yeah. So let's say if the calculation gives you a number which has a lot of decimal places, okay, a lot of decimal values, so round it off to 4 decimal places. And also, if the variable that is in the question, okay, let's say if the question is about weight, so when you write your answer, you need to write down the unit as well. Okay, there are marks given to 4 decimal places, and it's not marks given, but there are penalty given if you don't use 4 decimal places and if you don't write unit for your answer. Okay, that is if the variable has a unit, then you must put unit. If the variable does not has any unit, then it's okay to not write down unit. Okay, so please remember this rule of thumb. Remember. Okay, now the first category of tools that you can use to describe data. So this category is called measures of central tendency. So here we have 4 different tools, okay, under the same category: mean, median, mode, and mid-range. So the big question here is, what does mean, median, mode, and mid-range describe about your data? Let's take a look at an example. Let's say, okay, I collect data about this variable. Okay, I collected this variable, students' weight. Okay, I got myself 8 students to give me their weight. Right, so this is the data entries. These are the data values that I get. All right. So using this data value, I can calculate the mean. Okay, so I just use the calculator and I can easily get 56.5 kilogram. That's easy, right? But the big question here is, what does 56.5 58, sorry, that is an error. This is not supposed to be 58.5, it is supposed to be 56.5. So what does 56.5 kilogram tells you about the data? You might want to say average. Yes, I know average is mean. You're just changing the term. You are still not explaining what does average tells you about the student's weight. So you see what happened here is from having a list of data, okay, in this case we have 8 data values, but in real research scenario, you will have like hundreds, thousands of data values. Can you imagine that? Okay, so what happened is by using mean, median, mode, and mid-range, okay, by using measure of central tendency, you actually summarize all this list of data values, okay? You represent all these data values using one single value. Get it? You represent all this single value using you present all these data values using one single value, which is mean, median, mode, or mid-range. That is how central tendency helps you to describe about the data. It describes the central value of your data. It describes your data in a way that it helps you to find a single value, which is the central value that represents the whole set of data values. Itu dia. Okay, so that is the function of measures central tendency. So how to interpret this value, okay? Don't tell me the average is 56.5. That is not an interpretation. That is just telling me your calculated value, okay? So the right interpretation should be, okay, most of the students' weight is around 56.5 kilogram. Am I right? This is what mean tells you, right? This is what average is. It tells you a single value that represents the whole data set. Okay, class? Itulah dianya, alright? So, the measures of central tendency are used to describe an entire set of observations, okay, with a single value, okay, to represent. And this is actually the central value of the data set. Okay, class, so it is a representative, it is a value to represent the whole data set. That is what central tendency is about, okay? So let's look at the formula for mid-range. Let's just recall your memory. Mid-range is just taking the minimum value, add it to the maximum value and divided by 2. That is your mid-range. For example, here you just take 1 plus 8 and you will get, divided by 2 and you will get 4.5. Okay, mid-range is just a very rough estimate of the average, okay? It's a very weak representation lah. Okay, it is a very weak representation of the central value of your data, but it still works, okay? It can be affected by extremely high or low value. Next one is mean. Okay, I don't need to remind you on the formula, but I do need to emphasize on the notation used. Okay, so if your data is from the whole population, if you collected your data from the whole population, you should use mu to represent your population mean. Okay, if the data collected from sample, so you should use X bar to represent sample mean. Okay tak tu? Alright, okay. So as a researcher, you should know lah whether the data is collected from sample or is it collected from population. But as a student in this course, okay, upon reading the question, because you are not the one who collected the data, so how would you know whether this is population data or is it sample data? Okay, whether the set of data given to you, is it population data or is it sample data? So let me just tell you this so that you won't be confused in the future. For this whole semester, for this course, okay, any data set given to you in the question is sample data. Okay, so any data set given to you in this course, in the questions, in your quiz, in your assignment, in your test, in your final exam is sample data. Alright, okay, so please remember that. Moving on, this is how to find median. Okay, median is the middle number of n ordered data. You have to arrange them in ascending order from smallest to largest. Then only can you determine your median value. Now, if your sample ataupun your data has a size has an odd number, okay, if your sample is in odd number, okay, for example here 1 2 3 4 5, there are 5 data values in this data set. So this is how you find median. Okay, x n plus 1 divided by 2, so 5 plus 1 divided by 2 is 3, x3. What does x3 means, class? X3 means the third data. Okay, the third entry. So the third data in this arrangement is your median. Okay, nice. Moving on, what if your data set has even number? 1 2 3 4 5 6. The sample size is even number 1 2 3 4 5 6. So this is the formula. Okay, n divided by 2, so you will get x3 plus xn divided by 2 plus 1. So 6 divided by 2 is 3 plus 1, that is 4. So x3 plus x4 divided by 2, so that means the third and the fourth data, okay, add together and divided by 2, which means 5 plus 7 divided by 2, and you will get 6. Right? Okay, so that's how you determine median. You don't really calculate median, you just have to determine which one is in the middle. Okay, and finally mode. Mode is the most commonly occurring value in a data series. For example here, okay, 163785. Is there any data value, okay, is there any data value that occurred more than once? None. Tak ada kan? Okay, so in this case, this data set has no mode value. Mode is not exist. Mode does not exist. Sorry, there's some grammatical error there. Okay, next example. Sorry. Bising ni bunyi hon. If the data set are 1637835, okay, so look at it. Look at here. Is there any data value that occurred more than once? There is, which is number 3. Number 3 occurred twice, while the other data value occurred only once. So number 3 is has the highest frequency of occurrence, highest frequency of appearance in this data set. So in this case, this data set has 3 as the mode value. Get it? So finally, the third example here, can you see any data value that has the highest frequency? What is the data value which has highest frequency of occurrence? Yes, 3 and 7. So in this case, this data set has 3 and 7 as its mode value. Jadi kat sini, you can see that sometimes maybe a data set does not has any mode. Maybe a data set has only one mode. Maybe a data set has more than one mode value. Alright, okay. So these are the properties of mode. It is used when the most typical case is desired. So that this means your research objective lah. Okay, if your research focuses on the most typical case in your population, so you better use mode to represent your data set. The mode is used when the data are nominal. Okay. Right, because when your data is nominal, do you remember what is nominal, class? Nominal is qualitative data, right? Non-numerical data values, okay? So if you have non-numerical data value, you cannot calculate mean. Okay. And if it is nominal, you cannot determine median because there is no arrangement. Remember, nominal is the qualitative data that cannot be ranked. So that's why if it cannot be ranked, okay, so you should use mode to represent the whole data set. Okay, you cannot find median, you cannot find mean, and you cannot even calculate mid-range if it is qualitative nominal. Next, mode is not always unique. What does it mean? It means that a dataset can have more than one mode or two mode, or maybe it does not has any mode at all. Alright class, itu dia. The 4 different tools under the category of measures of central tendency, in which all these 4 tools, mean, median, mode and mid-range, has the same function, which is to represent your whole data set using one single value, okay, ataupun to represent the central value of your data set, okay, okay, so that it can be a good representative of the whole data set. A good representative should be the one in the middle. Okay, the best representative should be the one in the middle. Okay, apart from that, you can also use mean, median and mode. Please read on this later. Okay, please read on this slide. This is also important, but I don't think I need to explain or to elaborate this to you. You can read on this. Apart from that, okay, as a representative for the whole data set, mean, median and mode can also be used to determine shapes of distribution. Okay, to determine shapes of distribution. For example, if you have collected a set of data and you calculated the mean and you determine the median and mode. Okay, so this is for the case of quantitative data, numerical data. Okay, so if you have done all the calculations and you find out that this mean, median and mode, they all have almost similar value, very identical values. So if the values are very identical, most probably it's not going to be exactly the same value, but they are very similar to each other. So this means you have a symmetric distribution. Okay, which means that even though you don't plot the histogram, even without plotting the histogram, you can also determine the shapes of distribution using mean, median and mode value by comparing the mean, median and mode value. Okay, a symmetric distribution is bell-shaped distribution. So let me just remind you of how it looks like. So this is how a bell-shaped distribution looks like. Okay, now next, what if, okay, the calculated mean, median and mode showed you this trend. Mean is greater than median is greater than mode. So that means you have a positively skewed distribution or right skewed distribution. Your data is right skewed. Okay, so do you remember how right skewed distribution looks like? It's like this. Okay, and lastly, if your mean is smaller than median and smaller than mode, then you have a negatively skewed distribution. Again, without drawing the histogram, you can already determine the shape of distribution using mean, median and mode. Okay, so this is how a negatively skewed distribution looks like. Okay, now even though you can use mean, median and mode to determine shapes of distribution, please bear in mind that it is not the best way to determine shapes of distribution. The best way to determine the shape of distribution is by plotting the histogram. Okay, so this is just comparing mean, median and mode is just an alternative method to determine shape of distribution instead of plotting histogram. But plotting histogram is actually the best method. Okay, all right, so what else? In reality, maybe mode may not be right in the middle. Maybe not mode, median. Okay, median might sometimes be greater than mean or may sometimes be smaller than mode. Okay, it does not necessarily, the position is not always like this. This is just some extra info for you. Okay, the shape of the distribution may be identified by observing the position of the mode value. If your mode is closer to the left hand side, it is positively skewed. Okay, if your mode is closer to the right hand side, so this is the case if you plot histogram lah. Okay, that if your mode is more on the right hand side, so this is a negatively skewed distribution. Class, so that's all. Please try out these examples and these exercises to get more understanding. Okay, and I will see you on our next class, okay, to do some of these exercises, and I will pick more questions from the module. All right, so continue to listen to my next video on measures of variation. Okay class, have a nice day. Assalamualaikum. Bye.